This short video will describe a little bit of our discussion on power, and we'll do a simple calculation from one of the Monarch bicycles that we have in our lab, and we'll remember these calculations. We'll do them later when we're doing some different bicycle fitness tests. And also I'll show you some pictures actually of some different power meters. So power is the force applied over a given distance per unit time. So how much can you lift, for example, how far can you lift it, and how quickly can you lift it? So a strong athlete is not necessarily the same as a powerful athlete, right? So power is how strong you are, how much force you can generate per unit time. So the units are typically some unit resistance or force like kilograms, a distance like meters, and some time like minutes or seconds. And it's fun to think about these things. If we think of a power lifter versus someone doing general resistance training, powerlifting, there's specific lifts that power lifters do because they want to lift a lot of weight really quickly. Where someone doing resistance training, they're lifting weights to get stronger, not necessarily more powerful. So slightly different. In our lab, we have a couple different ways to measure power. And there's a picture on the right hand side. We have different bicycles that power can be adjusted electronically. So these bicycles are attached to computers, and there's actually a motor in the back of this bike that can apply resistance. So we can just tell the computer to have the person be biking at 100 watts, for example, and that's power that they will be generating. On Tour de France bicycles, all the bike riders will either have a power meter inside their pedals. So the forces can be measured by them pushing down on the pedals. They know how fast they're pedaling. They know how far they're going, so they can get a measurement of power. Also on Tour de France bicycles, the crank, so where the gears are, and actually in this crank arm, there are power meters. So how hard someone is pushing against this crank arm, that's the force. And then they know how fast they're going, how quickly they're pedaling or moving their pedals around, so they can get a measurement of power. Interestingly, in our lab, we also have a power meter for runners. So it's called a Stride FootPod, and I should have found a picture for it, but a Stride FootPod is simply a little computer chip that goes into running shoes. And it doesn't measure power directly, but it actually can calculate out an estimation of power. We've done a couple different experiments using this Stride FootPod, and usually runners don't measure exercise intensity by power. They measure it by speed or by like running pace, like a 6-minute mile, for example, or something, or by heart rates. But now there's some technology where they can use power to measure the intensity. So the bikes that we usually use in the lab are these Monarch bicycles. And this is in our lab, and a lot of exercise physiology labs and more clinical settings will have these kind of Monarch bicycles. Most of these are not electronically braked, meaning we will have to adjust the resistance. And the resistance can be adjusted by, there's a little dial near the handlebars, and that will tighten a belt. That is, this belt is surrounding the big wheel at the front of this stationary bike. And when you tighten this belt, this little silver pendulum will swing, and that represents the kilograms of resistance. So if you would turn the blue dial, tightening the belt, set that this pendulum swings to 1, that means there's 1 kilogram of resistance against the front wheel of this bicycle. And so we can actually calculate out a work rate or a power, and this work rate in kilogram meters per minute, so those are the units typically from this bicycle. And I just gave an example. If someone is pedaling at 50 RPMs times the resistance setting, and if this front wheel goes 1 revolution, that is equal to 6 meters. And this is 50 revolutions per minute, so revolutions will cancel out, and we end up with units of kilogram meters per minute. And so here's one very simple power calculation. Let's say we set the Monarch bicycle, we turn the blue dial, and the silver pendulum swings to 1 kilogram. So the resistance is 1 kilogram. Someone is pedaling at 50 revolutions per minute, and the distance of that wheel at the front is a constant of 6 meters per revolution. Revolutions will cancel out if we do the math. That's 300 kilogram meters per minute. And more typical units of power are watts. So the conversion in our ACSM conversion is simply taking 300 and divide by 6, or a more accurate number is 6.1. So 300 kilogram meters is about 49 watts. And this is not probably not a person's maximal power. This is pretty easy resistance. Although for more sedentary people or more clinical people, this could be their maximum power. The Tour de France article showed some power data. So the power data is saved either from the crank or the pedals, and it's saved on a computer and can be posted. And some of this power data has been posted. And here's actually one of the bike racers who is more of a climber. And they were going up a mountain or part of a mountain. So for the 11 minutes going up this mountain, this bike racer's average power was 389 watts. This next unit is relative power. So they simply took 389 and divided by his body weight in kilograms. And so for a mountain climber, I think this unit is actually really, really important, this watts per kg, or relative power. For more of a sprinter who is not going up a hill or not going up a mountain, this absolute power is maybe a more important number. During this mountain climb, his peak power for 8 minutes averaged out to be 417 watts, or 6.3 watts per kilogram. And you can look these numbers up. That's a really high, power output, and you'd expect that from elite level professional cyclists. So this is just a brief discussion of power and how we can measure it either directly with some of the electronically biked in the lab, or how we can calculate it out on our Monarch bicycle.